Well, today let's see how to draw the Lewis structure of nitrite ion. First point is the finding the central atom. There are two methods to find the central atom. First one is the central atom is the lowest electronegative atom, and the other point is the atom which has the ability of forming multiple bonds. That is the central atom. Between this nitrogen and oxygen, nitrogen has the ability to form multiple bonds, and nitrogen is the low electronegative element, and so nitrogen should be the central atom. So then we can make a rough sketch like this. And next step is the calculation of total number of electrons in valence shells of atoms. We know that oxygen is in 16th group, so it should have 6 electrons in the valence shell. There are 2 oxygen atoms, then multiply this 6 electron by 2, and nitrogen belongs to 15th group, so it should have 5 electrons in the valence shell. And there is a special thing to be considered, that is the negative charge of nitrite ion. This negative charge indicates that it has gained an electron, so we have to add this electron as well. Then altogether there are 18 electrons. Then in the next step we have to convert these electrons into electron pairs. Then we can divide this 18 electron by 2, so we can see there are 9 electron pairs. Then make a single bond between central atom and peripheral atoms like this. To indicate a single bond, we have to use one pair of electrons, and the other side as well there should be a single bond. And so far we have used 2 electron pairs, and there are remaining 7 electron pairs. These remaining electron pairs are provided to the highest electronegative element between nitrogen and oxygen. So we can see that oxygen is the highest electronegative element. Then we can provide electron pairs to the oxygen atom. Remember that oxygen or nitrogen cannot exceed the octet of their valence shell, because they belongs to second period of the periodic table. So we provide electrons according to the octet rule like this. Now we can see it has filled up with octet, and now we have 4 electron pairs remaining. Then these 4 remaining electron pairs also provide to the oxygen atom like this. And we have marked 8 electron pairs now. Only 1 electron pair is remaining. We can provide this remained electron pair to the nitrogen atom like this. And next step is calculation of formal charge. It is done like this. Calculate the number of electrons in the relevant atom before the formation of bond and after the formation of bond. The difference between these electrons is used to calculate the formal charge. Then consider about the oxygen. It has 6 electrons before formation of electron in the valence shell. Now it has 1, 2, 3, 4, 5, 6, 7 electrons. Remember that we used 1 electron from this bond when calculating the formal charge. Then it has gained an electron. We can see it should have -1 charge. And think about the oxygen. Oxygen should have 5 electrons in the valence shell before formation of bond. After the formation of bond, we can see that 1 electron from here, 1 electron from here, and there are 2 electrons here. Then it has only 4 electrons after formation of bonds. Then we can see that it has reduced 1 electron, and when electrons are reduced, it gains positive charge. It has removed 1 electron, so it should be +1 formal charge. Think about this oxygen as well. It should have 6 electrons in the valence shell before formation of bonds, and at the end, after the formation of bond, it has 1, 2, 3, 4, 5, 6, 7 electrons. Remember that we calculate 1 electron from this bond when calculating formal charge. So it has 7 electrons now. That means it has gained an electron. So it should have -1 charge, like this. In the next step, we can reduce this formal charge as much as possible. To reduce this formal charge, we convert this long electron pair into a bond, like this. There's a limitation. We cannot provide electrons more than the octet rule. Then I'm going to draw this structure again. There were a single bond. Now there are 2 bonds, like this. There are 2 electron pairs remaining on the oxygen, and like this. Then let's calculate formal charge of this oxygen. 1, 2, 3, 4, 5, 6, 7. It has extra electron still, so it should have -1 charge. And think about this nitrogen. 1 electron from this side, then 2 electrons from this side, and there are 2 electrons here. Altogether there are 5 electrons in the valence shell of nitrogen. So it has no formal charge because the electron amount in the valence shell has not changed. Think about this oxygen as well. 1, 2, 3, 4, 5, 6. It has 6 electrons in the valence shell. Consider that these 2 electrons only calculated for the formal charge of oxygen, and then there is no formal charge on the oxygen as well. This is the dot structure, Lewis dot structure. Then we can draw dot dash diagram. Then when drawing dot dash structure, we have to convert bond electron pairs into a small dash. That's the only thing we have to do. Then I'm going to draw it like this. There's a single bond, so to indicate a single bond we have to use a small dash like this. You can see there are 2 bonding electron pairs, so we have to use 2 small dashes to indicate this double bond. Then mark lone electron pairs like this. Like this. So we have drawn the Lewis structure of nitrite ion and subscribe my YouTube channel, and thanks for watching.